Okay, stream starting up. We have over 2,700 kilobits, settling down to 2,629. Oh, it's coming up and down, up and down. 2682 now. Still have a transcoder. Impressive. So this is what? Stream 17. Working on the ingestion library now. So given an example, abstract syntax tree and a bit stream, that when we parse that bit stream, we get back out a certain thing. So I have two test cases right now where we're reading a byte and a nibble. So we're passing like a number of bits into constructing the AST. Here's the AST. So it's really just a single format called foo that has a two-parter, or two statements, I guess. One is a part saying to parse an unsigned integer with a bound given. So the first one's going to be an 8, next one's going to be a 4. And to name it bar, and then the next statement is just to return bar. So I've been cheating so far in that the ingestion really just is returning 8 bits. Problem is that causes the nibble test to fail, because instead of getting a 1 out, we get an 18. So a couple things. We're cheating in the test. We're not actually using the we're sort of hard coding the number of bits on ingest. So we're not using the format at all. We're not using the formats at all. And also the buffered bit stream, it always reads 1 byte no matter what n you pass in. So I could either work on updating bitstream so that it uses that n parameter, or I could work on the ingestion library so that to actually make it use the formats. So minimally, we needed to understand from the formats that it has to take the top format and search for it in the hash map, find the format, and it needs to iterate through statements and at least understand the part statement and the return statement. I also wanted to make sure that I am doing the return type of ingest correctly. So right now it's this data type. And I think that's the right thing. Although I'm wondering if at some point it would be better to return like some kind of composite structure that represents foo in this case, right? So if we had more parts inside of foo, that we'd be able to like go and inspect them later. In the original tool, I think I just did this with callbacks, but I'm not sure. Maybe it'd be a good thing to go look at the C code first. So that was in decomposition. Decomposer. There are these callbacks, right? Set formats. So set formats was another call, I guess, because I kept it separate from the constructor. And so were the callbacks. Why do I have set error and set complete and then set callbacks as separate? Error and complete. I guess they're just two ways of doing it. Okay. Oh, actually, never even got the value out. We just decompose and we get a bool out. Whether or not it was decomposition was successful. So I guess it's totally reliant on the callbacks. So what's the component complete callback give us? Oh, a pointer to the component and its path? Huh. And I bet I just put the value in the component directly, right? Yep, I did. overall value. So this is what I want to do then, is put the value into the component along with these other things and just let that be the return value. Does this also remember the span? I don't see where it holds onto its original span. Maybe that's in the one of the other callbacks. No, those are the only callbacks. Hmm. The decompose program prints out spans. Let's see how it does that. Indents. Huh. Okay. Port component. But it's an error. It's complete or not. Print that if it's an incomplete. Hmm. We have this notion of complete components versus incomplete components. Okay, so it's recursive. Okay, here's where it is. It's offset. Skip right over it. So there's the offset in the bit stream of the first bit, and then there's the size. I think I will model it the same way in the Rust side. So let me change this test then. Okay, so that instead of a data that we get back, it should be a component. Component. Data component. We have data component and data value. That makes sense to me. So data component. This is data value. Component. Okay, so where was the, here it is, component. I have these nice little comments I kind of want to copy because I've already typed this out. This is the overall value assigned to the component. Here, look, I've typed this up. We could put that here, right? This represents a part of the structural hierarchy of data. It may be an element, leaf, or a composition of smaller components, composite. I don't think we need this, do we? If I do that, then I'm going to want an RC to wrap the bit stream. If I need that, I'll add that later. I suppose, yeah, we're recording what its format is, so don't want to add too much though at once. This is external dependence. One or more components outside of this component and its descendants depends on the value of this component. I don't remember ever using this. What is this from? It's only in the scripting? Huh. Well, I guess we're not using that until I actually need it. Okay, complete. Let me see how complete is used. Okay, it's true if we have a value in dereference. Why would we set it there? Oh, okay, this is if we're constructing a synthetic value. Yeah, well, actually, no, that's extracting a value, that assignment, right? I think so. This is if it's an L value and it's constructing a copy. Is component and not created. Okay, maybe not then. What's is component again? This flag indicates whether or not the reference must refer to a component and not a value. Okay, so that is where we're creating a part then. Why would it be complete why would it be always complete? I thought complete was only true if we parsed all the bits in it. Execute statement. I don't understand this. Why do we have if there's no value, it's complete? I don't remember why. I think we're skipping that too. Okay, error is if we actually have the error statement, right? And forget if it just marks the component we're in or if it marks it all the way back up. I think it should mark it all the way back up the tree, but I don't remember. Can I do find all references? Does this work with C code? Kinda does. Okay, the elementals will set the error flag, it looks like. Okay, if we're in a context with no bit stream, that's an error. If we try to parse something, that makes sense. If the bound is not an integer, if the bound is negative, inner bound blows the outer bound. If an argument had an error in being evaluated. Where are we now? This is obscure. This is if we get to the end of a statement and we can't dereference the statement's L value. I don't know what that would mean. I think that's maybe that's where we should have just assumed it would work. And that's the same thing for ignore, right? Oh, wait, no, L value is if there's a copy on a part. If we do a copy, which is what this does, or no, that looks up where we're going to store it. If we can't get to it, then it's an error. Yeah. And the same thing for ignore. And what's this one? Statement L value. That's ignore. Okay, what's this other one then? Oh, that's the arguments for an ignore. Okay, and that's the L value for an ignore. Okay. Accumulation. Yeah, all these reference. Basically, if you dereference something on the left-hand side and it doesn't go anywhere, then it's an error. Enable decrement. Okay. Okay, so this is how we perpetuate up an elemental, sets the error for the composite that it's in. If we can't find a format, it's an error. If we get an error statement, then it's an error. What's this return scope? Oh, right. So we could return out a bunch of statements because this is if we don't return. This is if we hit a break statement, a return statement, and this is if we should just stop completely due to an error. Okay. Yeah, okay, and this is perpetuating an error back up to its parent. So that's the answer then. Yes, these flags perpetuate all the way up the chain. And I don't know if we're gonna do that. Unless the component is the root of the hierarchy, this points to the parent. How is this parent actually used? These are all just to assign it. Okay, what about this one? Execute statements. Wouldn't a local parent be in the decomposition context? When would it ever not be? Oh, I guess it's well no, if we just remember what top level component or what component we're in, what format we're in. If we remember what format we're in, we don't need local parent. And that's okay, so we don't need any of these if we just remember what format we're in the context. Okay. So I don't need that one. Okay, so I think I will just put what we know we need immediately into the data, which is just the value for now. Okay, so then this is a data component. Like that. Data value. So we have to use that. Okay. Still not good. It's private. Public. Yeah, that should be public, right? Right. I think so. I'm putting the entire data thing here. This could be a little bit complicated, right? Because I could just fix it for now. Data component. If they're equatable, then this would work. I'll get the unit test working, right? Okay, so this is quickly going to get out of hand, I think. I think we're going to end up wanting to like get the ingest output, the data component, and then we're probably going to want to like inspect a few things about it, but not everything in it. Okay, I think the next thing that's easier to do is this buffered bit stream. So if we have like ingestion pass along, well, I have to get that n from the format first. Okay, but I at least can make sure that this does the correct thing. It actually uses that variable. So like if I change that to a 4, I would expect the other test, the byte test to fail and the nibble test to pass, but it doesn't, right? So now I can change the buffered bit stream and make the other test pass instead of this, instead of the one that passes now, the other one should pass. Okay, so I guess the idea is we can't just return the whole byte. We're going to have to take the byte and mask it by some mask, which is going to be calculated from n. Let mask equal, I guess the easiest way is to left shift 1 by n and subtract 1. And I think that will work. Let's see. No, they both fail. Okay, because this is taking the least significant bits. So it can't just use n here. No, I can't just use and mask. I have to shift the mask around, right? I have to shift left by, if it was 1 bit, it would be shift left by 7 to get to the most significant. So it would be 8 minus n. Okay, so let's compute that shift. 8 minus n. And so mask, shift left, shift. We got an, for the nibble test, I should have gotten a 1. I got a 16. Oh, because we have to shift it back down by n. Yeah. So let bits equal that, and we have to shift those back down. Bits shift right back down. Actually, it's by shift again, right? We shifted the mask up. Actually, the alternative would be to shift the input and then, yeah, okay. So that's I think a better thing. Rather than shifting the mask, we shift the bits. So we shift them right by the shift, and then and by the mask. Can I use order of operations on that? No, let's see. Okay, cool. So we passed the nibble test and we failed the byte one, which is expected because right now we just have it hard coded to do 4. If I put 8 there, we'll pass the byte test instead of the nibble test. Nope, we don't pass any of them. What do we get for the byte test? Oh, is this because it's always, wait a minute. Yeah, 8. What if 8, then shift is 0, right? Oh, is this a byte? Yeah, that's the problem. If it's a byte 1, left shift 8 overflows actually, right? Yeah, so I'm actually surprised I didn't get a panic. think the first thing we need to do is upcast it to U64. So that would be like if we just took this as a U64 and then shifted it. Now our mask is a U64. And I don't need this as. Now I should pass the byte test. Yeah, I did. And again, if I change that to a 4, it should pass the nibble test. Hey there, Stripe Monkey. What's that emote? OTT debug. Okay, so we're extracting the correct number of bits, but now we're not accounting for an offset. So I think before I go any further, then I want to get the ingest rather than hard coding it, is that we should actually have it be done through a statement, and then back in the test. Yeah, we don't need this one anymore. In the test right here. I guess I would make a loop here. Or just have two fields. Yeah, because I could have more data here. What if I just have two fields, like first and second? So how do we do that? Right now I'm counting on the value inside the data component, which is what we get from the return. I'm thinking like all things that coming up with in my head would require me to do more of the implementation. I'm trying to get away with the minimal baby steps forward. Let's just get these tests to work. So there's no offset in the buffered bit stream. It's just selecting a number of bits, either 4 or 8. And this, we should just try to get rid of this hard coding of a value. This value should come from executing a return statement. So minimally, we need to support, yeah, like I was saying last night, we need to support looking up the format and going through, iterating through the statements, parsing with part, and constructing something with return, which means dereference needs to work minimally. Okay. So what to do first? How about we look up the format in formats? And we don't have a test for error, so we'll just assume it always works for now. So let's change this from format to format name. So let format equals self dot, which we don't have stored here, so let's do that. Self dot formats dot get format name. Unwrap for now. Okay, and then we want to iterate through the statements. So for statement in format statements. Because that's a reference to a format, right? So now it's a reference to a statement. Okay, and we're going to be forming a data component. So let's make one before we iterate into, let's do it right up here. So let mute composite equals a data component. We should just make a default, right? Actually, we know that's format, so we can just have it get a copy of the format name, right? Pending update to Chromium Snap. 23 hours left. That sounds ominous. Okay, and then at the end, we're going to return composite. So we need to have a new that puts some default value in there. I think what I'll do is value should be optional, right? So let's go to data. Let's make this optional and give it a new. Pub function new. Okay, value name dot to string. Okay, and that's not correct. I wanted that to be like name, and then value should be none. Okay. I had nice comments in here for component. Where was it? I guess I closed it. Component.hvp. Here it is. This is the nick. Looks like I called it format. Oh, you're right. It should be format, right? Yes, it could. Yeah, because the name is assigned outside. In fact, I don't think we have a name here, right? It's if it had a name, that would be the key to wherever this ends up getting stored. Okay, so it's not name. It is where are we? Why is this not saved? I don't know why. Data. This is format. And we're gonna paste format. I guess it would be public also. String. The name of the format specification used to break down the component. I don't want to mess with borrowed strings. I'm just going to clone the name. We can change that later if we want, right? Okay. So that takes care of that. I'm just keeping that there for reference, but it should build now and it should fail both tests. Oh, the test doesn't even compile anymore. Because this should say some. And also we're missing a format. Format. Foo. To string. I guess we're doing our own formatting here. Okay. Still fail both tests, right? Because we're not done. All right. We're going to do something with that statement, right? We're going to match that statement. Okay. And then we got to do something for all of these kinds of statements, right? We can leave a lot of them to do. Let's fill this in where return was. So if we get a return statement right here, then this expression we need to evaluate there. But let's say that we're just going to hard code it for now. Can I get rid of that? There we go. Yeah, we're going to take this value and assign it to the composites value, right? Then that should allow me to pass one of the tests, at least. Nope. Oh, because we have a not implemented yet for part. So let's just have this do nothing for now. Okay, so we passed the byte test, failed the nibble test. Okay, so rather than hard coding that, need to be able to use the expression here and assign the value, whatever we get from evaluating the expression, right? So I guess we'll just assume that we can evaluate it for now. So we'll just do a direct assignment. So that would be expression dot evaluate. And we need to give it a evaluation context, right? Actually, I don't want to build it straight into the AST. Let's do just like I had it in the C code. Actually, why don't we make a ingestion context, and then it can have the evaluate expression because it knows the exact context in which we're evaluating something. That would mean moving the composite into some other structure, which is like the context. So did I put it in ingestion, I guess? Put it here, struct. Actually, it's a local structure, so it could just be context, right? This makes me feel like it's a bad idea because if I break ingestion into multiple modules, then I'm probably going to want to make this name not so abstract. But right now, but it's easy to rename things, right? So I think it's fine for now. So so we have the composite we're constructing, a data component. That's all we have for now, right? Oh, we also have should I put the bit stream in there? We might as well, right? Because well, hold on. If I'm going to call ingest recursively, this is a problem because it's owning the bitstream, right? Unless I get the bitstream back out. So maybe we borrow the bitstream mutably for ingest. Which means I got to change the unit tests. I'm surprised it didn't give me an error. Probably because I haven't fixed this error yet. All right. Yeah. So I think we want to put that reference into this thing, which means it will have a lifetime. Okay, we're doing it. Oh, actually, and then it's also generic off of some kind of bitstream. Okay. Don't know why I typed that rather than copy pasting it, but I did. Okay, let's make a new for that just for convenience. Or do I? I guess I don't really need to. We can just construct this directly here. Let mutable context. And then composite becomes this. There. And bitstream is bitstream, right? And then we're just going to end up returning the context composite. Okay, comment that out for a second. Make sure that I fix all the other errors. So what's wrong with this? Oh, it has to be over here, right? Okay. We're getting there. I'm gonna leave that there for now. Okay, so the whole point of doing this was that I can put this into context, evaluate expression, or actually evaluate expression because we can't overload the word evaluate. Okay, so we're gonna have an evaluate expression up in here. I'm wondering if these structures are really the same structure. Except for we do only want to borrow the bit stream for a limited context, so I guess that makes sense. So impl we need that at least, right? Of context underscore for I think this is the right syntax. Okay, so function evaluate expression self and actually I don't think we need to mutate the context to evaluate an expression. We shouldn't have to, right? We need an expression. And we're going to generate a value out of that. Okay. Optional value, I guess. Actually, no, we're going to say that we're going to get something out of that. Otherwise, it's going to be an error. Actually, then, yeah, we want to like kind of well, we're going to have that be an okay for now. And this is going to return a result. And we need a kind of an error for ingestion error. I guess we can call it our own error type. Blaze Labs, how are you doing? Kappa and sideways look. Back to you. All right, let's make an error. Doesn't have to be much, right? It's just an enum error for now. Okay. Just to get it to compile. And then that's where I'm taking this thing right here for now. Ka-chunk. Ah, that's what we need. This is self.content. Oh, that means it doesn't mutate. No, we don't need to mutate the context. We have a mutable brevis to the bitstream there, so that still works. Okay, cool. That's what I was hoping for. So what I want to do is I wanted to do incremental changes and make sure I'm not breaking other unit tests. Where is that? Oh, right. We're not borrowing the bitstream like we should. There we go. Why did it not like that? Cannot mutate immutable variable. Well, let's mutate it. Cool. That worked. Couldn't compile Y. Wait, what? Oh, it has to be mutable. Because okay. I thought we'd be able to get away with not making evaluate mutable. But even though we have a mutable reference inside there, we can't access it if we only have a immutable reference there. I guess that makes sense. Cool. So we're still passing the byte test. That's just what I want to make sure that we're that the data is still being plumbed correctly. Hey there again, Blaze Labs. Typing pop Nemo. I don't know what these emotes means. Oh, because I have the emotes only flag. I turned that off. How did that get turned on again? Is that why no one's been chatting? Gosh darn Twitch. Stupid Twitch. Sorry. So I've been going like 46 minutes with emotes only mode on. Ah. There. Now you can all talk. Thank you, Blaze Labs, for getting me to realize that emote only mode was on. So usually I turn emote only mode on at the end of the stream so that no one can come in while I'm not moderating the channel and just start spamming naughty words, right? So worst people can do is just do lots of emotes when I'm not around, and then I turn it off when I begin the stream. But somehow I got turned off, or I never turned it on last night, and so when I went to go turn it off, I actually turned it on, and I see that now in the history. I enabled it at the beginning of the stream instead of disabling it. It's one little word that I have to look really carefully and say, does it say enabled or disabled? And I didn't do that. Arr. Okay, I'll stop beating myself up. Okay, so we're still failing tests because we have this 8 hard-coded, right? So a couple things. The expression shouldn't actually do the ingest. That should be what we have done in part. So let's do that next, I guess. I guess I can just move this directly. We need to have some place to store it though, which means that the data component has to be able to have parts in it. Love the name DataDisintegrator. Why did you choose to go with Rust for your parser versus something like Python? Because I like Rust. So the stream has been a Rust stream for a couple of years now. That's the only real reason. It's just a personal preference. I could have done it in Python too. Wait, did you sent it in the channel and you also whispered it? Oh, you whispered it like 8 minutes ago because I had the emote thing on. Typed out a whole 103-page book and it didn't send. Yeah, sorry, eat bites too. Patata still papa. Hi. Why not use insert my language instead? Exactly. Well, it's a fair question to say like, why am I picking Rust? And the answer is because I like it. I think that's fair. What was I gonna do? I shouldn't just start randomly clicking things. All right, I wanted to compare. I wanted to grab the comment that I know is there in the C version of this. Because what I want the return statement to do is actually, well, the expression should see that it's a reference expression, and the reference expression should look up the value from the keyed children, really, right? Yeah, so we want this comment back in here, not here, back in data component. So I want to put it here, I think. Okay, public keyed children. I'm not too Well, I'm not convinced that that's the right name to call it, but that's what I called it in the C version of the code. Trying to learn more about parsers and grammars, like what makes a good versus bad one. I would say that a parser is bad if it's ambiguous and you have to use arbitrary, you had to add arbitrary things to the grammar to disambiguate it. And a good one would be a grammar that intrinsically is non-ambiguous. There's not much to parsers other than making sure that the grammar rules are non-ambiguous so that your language always predictably reduces down to the right form in memory. Or I should say, more generically, that you get a predictable output based off of your input. So key children, index children. Children's not really the best name for this. It's like parts, right? Thing is, it could be a part and it might not be a part. Maybe that's why I called it children. I think we'll just keep it for now. So the key children is a hash map from a string to another data component. Hash map comes from collections. Okay, so then I need to initialize that. You're interested in using a parser combinator sometime in the future for the fun of it. I can go over, if you're going to do it in Rust, like what I did. So I broke things up. And let me show you in my document folder, I have a terminology. So this is also sort of a nice intro to what I'm doing. DataDisintegrator pulls apart all the bytes of some binary file or stream, assigns meaning to each one based on a description of the format. So, for example, here's a description of GIF file format in my DSL. Right, a GIF has a header and ends in a trailer, and the header's got a string signature and version and all that. So the pieces of the tool are the lexer, the parser, and the ingestion. So lexer turns a program into a token stream, right? So something that turns that into, let's see, right into this. And what I used for that was something called logos. I'm not seeing the lexer's token. What did I rename it to? I forget. Output, that's what I called it. Yep. Too many windows, let's close some of them. So I'm using logos to make the lexer. And so I used to have this generate the token type directly, but I wanted to have a one layer of separation between this and the parser. So it's just the output of a parser or of a lexer. The output of a lexer is are these possible things that turn into tokens. And what's neat about it is we use macro attribute macros to define all the things that the lexer needs, and just the deriving logos gives you the lexer. So generally what you need to do is tell it what to skip, that's your white space, what are your reserved words, and then how to match different other kinds of tokens like literals and identifiers and yeah, symbols, strings, that kind of thing. And then I have it convert the output to tokens. It's mostly a one-to-one, only I'm basically copying it to a type which is devoid of the which is separate from logos. It looks like this. So it's like that output enum tied to logos, but without any of the attributes assigned to it. So this is the interface of the lexer on the output side, and the interface of the parser on the input side. Back to terminology. I should Said that. So the second part is the parser returns that token stream into an abstract syntax tree. So for me, the abstract syntax tree is what you were kind of looking at a little bit ago. Like, was it the top level is format, which is not open in my editor right now. Here we go. A format is a bunch of statements. Statements could be things like describing the part of some piece of data. Could be conditionals, could be loops, could be return statements, all that stuff. Because like we were seeing with that GIF format, that's what this is a format. These are the statements in the format. The statements that actually do the parsing are called parts. So a header is a part, and in the header there are two parts of a header. A part has can have arguments, but it usually has a bound, like how many bits it has. Usually has a format and usually has a name. And these other things are for other things you might do with parts. So yeah, the parser constructs that stuff in memory, and then in ingestion we use that AST to break down the binary data. And that's what I've been working on today. Is given an abstract syntax tree like this, where we have foo has a part called bar, which is an unsigned integer of some number of bits, and then we're going to take what was parsed as bar and return it as the value for foo. That when we give it this byte, that we should get back out that for a byte. And if we want to make, say I made the AST parameterized, right? That number ends up going into the bound of bar. So bar's bound is whatever we pass in. So if bar is 8 bits, we should get back out the whole byte. But if we say bar is only the first 4 bits, then we should only get back the first nibble, which is a 1. So that's what I've been building up using, like, as much as I can, test-driven development, is the ingestion from going from the AST and the input bytes to the right now we're only testing that the format is correct and the value is correct, but I also need to test that the components, like the bar, is in there with the correct value and all that stuff. If ambiguity is bad, is there a way to test or measure the specificity of a grammar parser? Actually, I don't know how to do that. For me, it's just whatever parser generator you use will either say it's ambiguous or not. And so it would be a bad grammar if you just had a ton of ambiguities and it failed to generate anything. And I would call it a good grammar if it was non-ambiguous from the start. A so-so grammar would be one where it starts ambiguous, and so the parser generator errors out, and then you have to go in there and tweak a few things. Even if the language itself is incredibly specific, it can still be ambiguous as to what was intended, I suppose, because the grammar is only telling the machine how to do its part, right? If we look at like this GIF format, this is just telling the machine how to pick apart the bytes and what names to assign to certain things. But it doesn't actually show the image on the screen, right? The most it will do is say, here are the bytes that you would use to decompress and form the pixel array. So it's still sort of ambiguous what was intended, right? Did we want to parse the GIF file just to get the pixel data? Did we want to parse it just to get maybe just the size, width, and height of the image? That's still ambiguous. But that's why I have this third level after we compile. I close it again. Yeah, this ingestion sort of when it breaks it down into elements, like I intend to actually have a fourth step called the interactive part, where we can script and have a user interface around the component hierarchy. So the output of the ingestion is going to be this component composition, this data, right? Where we've broken the data down and we know what its format is and we know what its value is. And now it's up to some other tool like a script or user interface to show this, and then for the user to know what to do with it. Okay. Yeah, this isn't gonna compile because I'm missing something, right? I am missing. Oh, and it tweaked the format on me. Let's not have it do that. It's keyed children. I'm just gonna type this directly. In fact, I can type that much. No, actually, let's use maplet for filling in the values. It's hash map, right? And it's gonna be bar is another data component called bar, and it's not going to have keyed children. So this we could just say hash map new. Its value is also going to be 12, and its format is going to be UI. And that's all we're going to say about it right now. Mismatch types. Because that's got to be to stringed. So this might get really ridiculously complicated, and I might want to, like, instead of have an expected output, maybe what we would do is we have a different test and not use test case. Or maybe the expected output becomes like a validator, and then we make it a function, and then we put a function in here that just looks for certain things in the output. But then this sort of defeats the point of test case. In fact, test case is already just an assert. Just wrapping this line, really. That's enough though, right? Then we don't have to copy that line and then, well, except for this macro makes formatting a real pain. I'm starting to think I shouldn't use test case for this. Maybe. Maybe. We'll get there in a little bit, though. Not right now. Okay, I'm just making sure this compiles again. Failing both tests now. Oh, because it bar isn't in there. Yeah. Ugh. I need to probably do this sooner rather than later to just convert the test cases back down into tests again. Mm. I'm just thinking like I'm gonna have a ton of tests, and I'm gonna want to have a subfolder called tests and break the test down, right? Or maybe not. I don't know. Just thinking to myself, what am I gonna do here? The other thing I can do is I don't have to literally type the AST. I could leverage the parser as a test dependency, and then write, because the unparsed version of that, like the uncompiled version of that, is actually pretty simple, right? So how would I print it? Like let I don't know, formats equal. You do a multi-line string, they can do it like this, right? And I say like foo UI bar. Here's where I'd have to fill in the bound. So this is much easier to express. Why did I put that on another line? Can I have it not format that? That's much more concise than listing it all out, right? And we can just depend on the parser working for these unit tests. So kind of like depend on the parser for our unit tests here. I'm tempted to do that. Then I wouldn't even need this function. I could just have a literal format for each test. But yeah, I need to take a quick break. I'll be back in a few minutes. Did you guys enjoy the chair stream? Yeah, today, porting more of the grammar. Actually, that's not right. Let's fix that today. Edit com. Today. Let's say working to establish the ingestion library. That's what we're working on today. Yeah, I think I've convinced myself I want to do this. Actually, can I we're not even gonna need to do the format stuff. So hold on, let's get this working. So rather than having to do all this, let's just leverage our own parser. So there's a lot of big chats going on. Let's see. Okay, so there can be inherently hidden meaning in a language definition since there is a human on the other end making it. I looked at the repo for Lollipop, and he mentions usability and compactness are key features. So I guess in that case, that would be the intention. Like the phrase not X in foo, you may have an implementation that specifies not X in foo or not X in foo, but that doesn't make it any less ambiguous as to the extent intent, especially for people who don't know the language well. So you mean like the language seems ambiguous unless you know the hidden order of operations, maybe? Okay, so whoa. It started dragging and scrolling, and that was not ideal. I want to use both the lexer and the parser here, right? And so I want what's in parse, really. No, not parser. I want parse. There. Yeah, I want this. I want that. So literally it goes like that. And this we'll do on an unwrap. And that's what we get for that. And why don't we split this up? So this would be fn compile formats. String, same return value. So that we'll put somewhere else, probably put it there. And that's formats. And then I don't need all this garbage. I don't need all the raw AST. Let the parser deal with that. So import the lexer, import the parser. Okay, and then this would just say compile formats. There we go, much more compact. Okay, then I think we're not going to be like looking at the complete data component because it's way too much. I think what I want to do is break these test cases up into tests like this. So test case, well, what are we calling the overall test case? Test ingest a byte. What will this be parsing? I'm glad you asked me that. I don't have the intro video yet, but here's a real quick rundown of it. It's called DataDisintegrator because it pulls apart all the bytes of some file or stream, and it assigns meaning to each one of those bytes based off of the description of the format written in a domain-specific language. So these are the different elements of it. There's a lexer to turn an input program in a token stream, and then we use that to to make an abstract syntax tree, and then we use the abstract syntax tree to break down the data into elements. So for example, we start with like something like this. If we wanted to parse a GIF file, we would describe the format of a GIF this way. So it's kind of like a combination of a structure and a function. So structurally, a GIF starts with a header and ends with a trailer, has some data blocks in it. But functionally, you would parse it in order, and you might have some loops and conditional logic, because like data block, for example, there's 0 or more of it. And you might want to use conditional logic to detect errors. So it's the ingestion format that's going to actually walk through the compiled form of this along with the data to generate the output. I'll just give you an idea of what that looks like. So given a GIF file, like when it runs through the AST for this, it's going to say, okay, well, let's parse the first 3 bytes as the signature of the header as a string. It's 24 bits long. It's that, so it's not an error. And then next 3 bytes is 89A. And the next 2 bytes is 44 and a 1, so that's a 300. And so on, all the way down to the end of the file. By that time, we'll know that there are 61 GIF data blocks and ends in a trailer. So I'm porting that to Rust because I had written it first in C like many years ago. And then I'm going to add scripting and a user interface. And like one potential application would be similar to the data dissectors in Wireshark, where you can, if you describe the protocol stack using this DSL, then you could take these bytes and run it through the tool, and it would give you something like this. And maybe you'd be able to click on different fields, and it would show you which bytes those are. You might be able to edit the bytes, and it would reinterpret the data. You can do all sorts of cool things with it. And it's mostly just for fun. Isn't any language ambiguous until you know it? It depends on what you mean by the word ambiguous, I think. The more experience you have, so ambiguous means that it could have more than one meaning, right? That's what ambiguous means. So if you don't know a language, then yeah, sure, every word is ambiguous because it could mean anything. You don't know what it means. The more experience you have with language, the more you often start seeing similar patterns with the same intents in mind. I think that goes beyond language, especially evident in chat, because if you compare chat with actually talking in person, chat has a lot less so-called intent encoded in it, right? Because we're missing the body language. We're missing the forcefulness in which you're speaking the words. We're missing like maybe the stress you put on certain words, not others. So it goes beyond language. It's also, intent also can be encoded in things that go beyond the language. That's why you're asking if there's a way to measure it. Heard about Chomsky's hierarchy? So now we're getting into the philosophy of languages, which is totally beyond me. I think there's a distinction between not knowing a language because you don't know it and because it's ambiguous. Yeah, that's what I was trying to say. If you don't know a language, it's not that the language is ambiguous, it's just that the words are ambiguous to you because you don't know the language. Yeah, context is lost. Exactly, that's what I was trying to get at. Intent sometimes requires context, not just the language, which could be true for programming languages too. This might not make any sense unless I put it into the context of this is a file format, and we're going to break the file up into its components based off of the format. So saying that ambiguous is just that there are multiple ways to do the same things. No, it's ambiguous means that the meaning, there could be multiple meanings and you don't know which one to pick. So here, boil it down to something very clear. A plus B times C is ambiguous. That's ambiguous because it could be A plus B times C, or it could be A plus B times C. There are several ways to make it unambiguous. One is to establish an order of operations. So we say we do the multiplication first before we do an add. That's the traditional way in math that you'd make it unambiguous. But if I didn't say that, or if I said that specifically plus and times are of equal precedence, then this is ambiguous. I'm not giving you enough information to say which operation I want you to do first. So to me, that's what ambiguous means. It means that this statement, a plus b times c, could have two meanings, and we don't know which one is to pick. Study grammar, parsers, and compilers in university. I already forgot all that. Just remember some terms like context-free grammar. That's why Rust is cool. Usually it's easy to understand the context when looking at the code. Yeah, if you're used to the language, I guess. PEMDAS. I don't know. I don't know or follow PEMDAS. What's PEMDAS? Anyway. What's PEMDAS, precious? I'm working on the ingestion library, and I was working on the unit tests, right? I want to make the unit tests easier to write. So I was using the test case crate. I don't think I'm going to use it anymore. I'm going to like let AST equal that. And then we're just going to hard code this line. Actually, I'm not going to hard code it. I'm going to make another helper called ingest. Data composition. I forget what I called it. Ingestion new. Okay, so we have to have like the input. So ASTs. That is one of these things. And then we need a bit stream. Let's keep it simple and just say it's a buffered bit stream. So bits. Bits. And then we have the format. You know pandas. I know. I was thinking I know pandas too, but I don't know what PEMDAS is. It's order of operations: parens, exponent, multiply, divide, add, subtract. Except in my grammar, it's not exactly that. Actually, it's easier to show it in the old original Bison grammar. Where is it? It's around here somewhere. Here it is. For me, it's not PEMDAS, it's all that. So I guess if it's PEMDAS, it's reading it from the bottom up, right? So these are the ones that actually are important. So for me, it's, I guess parens is there too. So parens, yeah, of course. But then we have not, flip, negative, dec, inc, left shift, right shift, div, mod, multiply, minus, plus, less than, greater than, less than, equal to, greater than, equal to, equal, not equal to, mask, exclusive, inclusive, or set membership, logical and logical or. So I have a lot more than parentheses exponent. I don't have exponents, but I do have the unary operators and the shift operators that kind of take the place of exponents. Multiply and division are on the same level. Addition and subtraction is on the same level, but we're missing all of the bitwise and logical operators. So in Bison, I made them unambiguous by defining the order of the operators and also the associativity. In Lollipop, you can't do that. So we had expression tiers. So we had 12 tiers from 0 to 11. So each tier captures one level of operator precedence and also the associativity. So like in is a non-associative operator. So we have the next tier on both sides, but logical and is a left associative operator. So we have the recursive rule on the left and then next tier on the right. Okay, Mr. Balrog, I'm trying to see the pun or joke in that, and I don't see it. Is this the first time Mr. Balrog is actually not making the first statement in chat a pun or a joke? Okay, so what's the discussion going on here? Feel like I'm struggling to understand the concept of ambiguous encoding because it's a bit ambiguous. Yeah, there you go. Very meta of you to say that. Don't know anything about Rust, just interested in how I'm approaching the data parsing. Okay. Maybe I should get back to actual Rust. Yeah, the data parsing. Some of the interesting things I think are the buffered bit stream. I was going over this yesterday. If you're learning Rust, this is maybe a great way to learn lifetimes, which are these things, right? So why do I have a lifetime here? It's because I want my buffered bitstream structure to borrow some data. I don't want to have to copy the data because the data could be enormously huge. And there's no point to copying it because we're just going to be inspecting the bits. We don't need our own copy. So the way I define this is buffered bitstream holds on to a pointer to some data and it doesn't own the data. It's just borrowing the data. And that's by an immutable reference with a certain lifetime. And in order to store a reference inside a struct, you have to take that lifetime and expose it on the structure itself, which is fine and cool. It basically says our structure can't live longer than our borrow of the data. So the data has to be owned by someone. It's going to be owned probably by the caller of new is going to give us a reference to their data, and then we're just going to kind of package it and hand it back out, saying, okay, here's your reference kind of packaged as a nice object that now has a function called bits and lets us like select a subset of the bits from that data. I have this mutable because in the very near future, I want the bitstream reader to remember how many bits it's already read so it can skip them. So it gets a little complicated because fundamentally the type is byte and not bit. So we kind of have to like cut up some bytes, and then we might end or begin not at the beginning of a byte, but in the middle somewhere. So the amount we shift around and the amount we mask is going to get kind of complicated. You can imagine you might be on the last bit of a byte, and then someone asks you for 2 bits. So you're going to need the last byte of the last bit of the byte you're on, and then the first bit of the next byte, and you need to glue them together, and then now remember that you've eaten 1 bit of the second byte. How are you able to make the grammar self-describing, and why did you do it? My grammar is not self-describing, but Lollipop's grammar is self-describing. No, how they did it was they do I still have that open somewhere? Yeah, they actually wrote their own grammar in their own language. So this is a self-describing grammar. So this is a Lollipop grammar file that describes its own grammar. And you kind of see that when we have grammar on the outside and then we have grammar on the inside. But I didn't do that. My language is not self-describing. Your son asked you if you were pyromaniacs. You replied, yes, we are, son. Okay, there you go. There's what we were expecting from you, Mr. Balrog. But you know how it's going to be processed, then it's going to be processed the way you want. So I said languages are less ambiguous if you know them. I think you're using the word ambiguous in a strange way to me. To me, ambiguous means something very specific. It means that given a statement in a language, it's not clear. Like even if you know every aspect of that language, it's still unclear what you meant. That's ambiguous. But it seems like you're using the word ambiguous to mean like not understood, right? To me, ambiguity has nothing to do with understanding. It has to do with that there are multiple things that might be expressed, and you don't, and the receiver of the information doesn't know which one. So literally, A plus B times C. It's ambiguous if plus and if add and multiply are the same order. So you have to impose a rule saying you multiply first before you add. Now it becomes unambiguous. I don't know why you think that that's funny. Ambiguous means something very specific. Multiple possible meanings without additional context. Yeah, exactly. So it has nothing to do with understanding the language. That's different. Are ambiguous things just more difficult to know? No, it's not. It's not a case of difficulty. It's a case of it's very cut and dry. It either means one thing or it could mean more than one thing. Meaning one thing is unambiguous. Meaning more than one thing, or the possibility of it meaning more than one thing means it's ambiguous. Nothing to do with understanding or difficulty. It's just that the set of things that a list of tokens might mean has a cardinality of one, or it has a cardinality of more than one. That's it. Let's move on. Okay. Oh, it doesn't like my comma there? Because I don't have an end parentheses. Yeah, I do. Right there. Probably because I have to hit save, and now it interprets it. Yeah, it's just a Rust analyzer thing. Right, that should be mutable there. We don't need to do that there. Okay, and then... Okay, archification, you're still like trying to use the word ambiguity differently, and that's okay. But it just makes it difficult for me to discuss it with you if we disagree on what the terminology is. I think like most misunderstandings, it's rooted in different terminology. So we're just using the word ambiguous. We're using the word ambiguous differently. They have different meanings for you and me. Am I using I3? What's I3? I'm using I64 here. And I'm using U8 and I'm using U64. What do you mean by I3? I3 is a window manager. No, I'm using XFCE. Okay, what's wrong with this? Why is it not like that? I'm missing some syntax here somewhere. But I don't see it. Maybe it's rooted up here. Or down here somewhere. Oh, probably because of this being incomplete. We're going to get rid of this anyway. That goes away. This, yeah. Let's just comment all this stuff out. There we go. Okay. What did I name it? It's whatever this returns. Data component. Data component. Yeah, component is a kind of composition. All right. So yeah, the test is going to ingest. So like let data equal ingest AST. Oh, we have to make the bit stream. Here we go. Let bits equal that. Mutable bits. And foo for the format. Mutable bits. Okay, yeah, so all I really wanted to do in this test was to make sure that the value, so assert equal expected, the expected is some 12 in hex. Actual is data dot value. There we go. And then I can get rid of all this because all that stuff is sort of unnecessary. And then, yeah, this nibble test, right? So it's just another test. Okay, yeah, I like how I'm structuring this now. A nibble is constructing a foo AST with a 4 instead of an 8 in there. And we should get back a 1, not a 12. So all that goes away. It's much easier to read. An array of bytes, for instance, is ambiguous. I don't think of an array of bytes as ambiguous. It just is. It's an array, and each element of the array is a byte. But although I guess whether something's ambiguous or not depends on like how it was used or presented. So yeah, I guess if I took an array of bytes and I handed it to you and I didn't say anything, then what the meaning of that gesture would be ambiguous. It'd be like, does he want me to look at it? Does he want me to like take a byte out? Does he want me to add a byte in there? Could talk about the same thing like that for hours. Drives people nuts, and you're self-aware of that. Do you like driving people nuts then? I guess it's not that you like it, it's just that you like talking about the same thing, and the side effect is it can drive people nuts. Okay, so then we don't need all of this stuff, right? Don't need hash map, don't need test case. Let's just remove test case from the dev dependencies because I probably won't use it here. Many horses were beaten this day. Aw, poor horses. Does this read well now? An AST is an example foo AST with 8. Bits is a buffered bit stream. Data ingest with the AST. These bits with format foo. We should get back 12 for the data's value. Looks good to me. But we're failing both tests. Because we panic on unwrapping a parse error. Ooh, I have a parse error there somewhere. Oh, there's no semicolon. There we go. Still a parse error? No, now we're getting a none for the output value instead of some integer. Okay, so we're getting closer. I thought I put, yeah, I put the value in there for the return statement. Oh, we didn't have a return statement. I took that out. That would explain it. We want to return bar. There we go. Passing the byte test. Okay. So now I restructured the test. Now let's get 4-bit data to work. The only reason it doesn't work is because I have it hard-coded somewhere in evaluate expression. Right, it's hard-coded as 8. So the important thing is that instead of actually ingesting it here, we want to ingest it in part, store it as a value, and then return should retrieve it back out. Mr. Balrog, you're just like you're taking that gasoline and you're taking that blowtorch and you're like, let's add fuel to this fire, right? No, it wasn't you, Archification. It was Mr. Balrog. Mr. Balrog is adding fuel. You're just fine, Archification. Okay, I guess I'll first start with the part statement. So this could just hard code the fact that we're going to parse 8 bits and we're going to store it. So let's do it that way. I want this out and I want it here. And what we're going to end up really doing is we're going to say context Posit dot keyed children dot insert. For the key, we want name dot clone. For the value, I want that. Oh, it's going to be itself a component. So let part equal, and the format name is in there. It's just format. Mutable part, right? And then, yeah, then that's parts dot value. And then this is part. Name is an option string. So let's unwrap it for now. That's not the correct thing to do, but I'm just trying to get the test to work. Option sum. Context big string. As ref. There we go. And then return. All right, so this should actually, let's just hard code this right now to look up the value. So it should do a self dot component dot name, no, not components, keyed components, right? Composite keyed children get bar unwrap. This is horrible, but I want the value out, right? Dot unwrap. Horrible. Horrible, horrible, horrible. Yeah, it should be as ref unwrap clone. And we can't do that because it's not clonable, right? Found data value. It doesn't implement clone, yeah. So let's make it implement clone. Clone. Then as horrible as it is, it'll actually work, right? So now it should retrieve the value that part stowed in there. Yep, still passing the byte test. I'm a cashew. I wish I had either the memory or the database in order to pull out one-liners like that, Mr. Balrog. I'm impressed. Yeah, Blaze Labs. The other thing is like etiquette and socialization is hard to do on Twitch. Hard to do. Okay, now which thing do I want to clean up first? This is almost correct. Problem with this is that it's a result. Okay, so if the expression is bad in result, I think I wanted to like mark the whole composite as an error. But what should its value probably be? It should just not assign a value, right? So it should only be like if let okay value equal that, then that equals the value. Some value, right? Wait a minute, isn't that just the same thing as saying, it's almost the same thing as saying that context composite value equals context evaluate expression dot okay, only we might have multiple return statement. Actually, no, we're only gonna have one return statement. So I might as well do, for now, this dot okay. And because I was going to handle errors later. So that's good. So I either fix part or I fix evaluate expression. I think I'd rather fix evaluate expression first because that's looking up references. So let's do this. Switch expression. What am I thinking? Match expression. Got all these types of expressions, right? And the one I really care about now is reference. R. Okay, and then I think we can actually use the name from R. So it would be get name. Let name equal R dot 0 dot first or next. Is there a first? Yeah, first dot unwrap dot ID. Borrowed. Make sure that that works. Cool. It worked. So we're so it would fail if I were to like use a different name in the reference. So it would actually panic right now because we're doing an unwrap. Let me test that. So here, if I did like if I did a baz instead of a bar, now it should panic. Yep, it panics at exactly where I thought it would, right there. Getting there. Adding some rules for the chat probably won't hurt. What kind of rules do we want? Hold on, I missed some stuff. Was complaining when I was programming a chip 8 emulator. Good luck. That's the first time chat is I was complaining when I was programming a chip 8 emulator. Good luck. I don't even know what to do with that statement. Okay, you were complaining when you were programming a chip 8 emulator. What do you want me to do with that? And now you're saying good luck. Does that mean that you're leaving? So the first thing you chat is something like some random statement and then good luck. I guess I don't, maybe if that was that a joke, I don't get it. What's chip 8? Anyone else in chat worked on emulation before? Yeah, I don't know. All right, I'm basically making baby steps towards making this AST actually functional with the bitstream. And yeah, there's a lot of because there's a lot of parts, there's a lot of to-dos in the ingestion. I'm just doing the minimum, and then my goal is once I get it to work, then I look at all the to-dos and I try to craft a test that hits each one. So this is like doing the minimal steps to actually require me to fill in the to-do. By the end, I should have the minimal amount of unit tests that hit all code paths. Right? Especially when I have these unwraps. So I should have no unwraps and no to-dos at the end, right? Absolutely none, unless the unwrap is something that is just to adapt a result or an option that always is irrefutable, like it's always some or okay. Otherwise, it can be a panic, and then we don't want that. We actually want to handle it. So I need to have a test case that proves that we're handling it correctly. Okay, here that's hard-coded, right? Why don't I work on that next? So rather than just assuming the part should be hard-coded, we should look at the format, I think. And if it's a built-in, the built-in should do that for me right now. Oh, sorry, I'm Spanish. I meant that. What are you programming so difficult for me? That did not translate very well, the way you said it. What you said is that you were complaining in the past when either that you were programming a chip emulator or you were complaining about something that you're not specifying back when you were programming a chip emulator. Let's say what you really meant was that programming is difficult for you. You complained so you got frustrated when you were coding the emulator. Good luck meant that good luck coding the compiler. Oh, okay. So the good news is that the compiler is done. Right, we're right now using the AST that the compiler generates to actually parse stuff. So if I go back to my terminology, the compiler is this, right? That's the compiler. Compiler turns an input program into an AST, an abstract syntax tree. So we're done with that. We're working on the ingestion now. We're using that AST the compiler constructed in memory to break down binary data into elements. So that's kind of the intent of my unit test to express that we're taking so this is doing the compilation, right? That already works. We're going to take the AST from that, the abstract syntax tree, and then we're going to take some bit stream and we're going to say ingest those bits. Actually, probably I should order this different, right? So the statement should read, we're ingest these bits using this abstract syntax tree in this format, right? And then we get a value out of that, which is the top level of the return, or the return in the top level format. And then we're just making sure that the value is what we expect. So if this 8 here is an argument when we construct the format to say like how many bits should be in bar, right? Parse it as an unsigned integer. So if it's 8 bits, we should get all 8 bits out. We should get the 12 hex. But if we only ask for 4 bits, we should only get the top nibble, which is the 1. In fact, we could actually extend this and say, do it again, and then we should get the 2 out. That will prove that, oh, except for we can't use the same AST. What if we let it borrow the AST? It doesn't actually need to consume it, right? Let's make ingest borrow. Yeah, because that can just borrow it. But then I would have to have a lifetime. Actually, that lifetime is not such a big deal, right? We can do it this way. And then we just repeat this again, right? Because I have to say this again here. And that's not a big deal. Now we can borrow the formats, and it's already a borrow, so we don't need to reborrow. Yeah, there we go. So yeah, the whole this is saying that if we already ingested the top nibble, when we call ingest again, now we should get the bottom nibble, right? You understood what Pablo was said? I don't know how you could have. Would not expect be better used if you expect something to always be there. But the unwrap is temporary, Nightshade dude. I want to be like able to when I ask myself the question, am I done? The way to answer it would be to search for all unwraps and all to-dos. To me, an expect means I've already evaluated an unwrap and decided that yes, it's valid to panic here. And if it panics, I want to actually have it print something to the user. So I very rarely use that because I don't like panicking inside of a library. I think panic is like more appropriate at the top level app. The library should should percolate or like return the error, should propagate the error up to its API layer. Let the app decide whether or not it wants to panic. I think one of the worst things you can do as a library developer is to call the exit function or to panic, because you're making an opinionated, you're making a decision for everyone who uses your library that, hey, if this situation occurs, we should always panic or we should always exit the program. And then the user of the library is going to be really frustrated, like why can't it just return an error to me? And because we don't want to panic, we want to like show an error screen message to the user in that case. So that's why I don't use the expect or unwrap in a library. And I could do an expect, and that actually might help me if I plan to like take a while before I get back to this. I might say expect, because then the string becomes a hint to me that so in this case it would be this assumes the part has a name, right? And then when I come back to this later, I'd be like, oh, I actually clicked something outside the VM I didn't mean to click. No, I don't want to play World of Warcraft now. There we go, quit that. So yeah, this is a statement to future Raimu saying, the reason why we're panicking here is right now we assume the part has a name. So my goal would be remove the assumption. So like the correct thing to do here is if part doesn't have a name, we're not going to insert anything into the key children. So actually, let's just solve that right now. It would be if let some name equal name, then we would do this without the we wouldn't need the avsref either, right? It's just that. There. Now I've done that. Now there's no more unwrap or expect, right? So if I'm gonna do it very soon, I don't bother putting a comment or a to do or turning it into an expect. But I might if instead I'm not gonna handle it for like a couple days. No, it was not that, Tristos. I don't really want to add a permitted term, but use it in an okay context. No, I opened the battle.net by accident. The icon's right below my VM right now. Okay. So yeah, anyway, we took one of the unwraps out. This I kind of want to put a comment because it does not neither an unwrap nor is it a to do. So let's put that here, to do. Or I could just do this next. Don't hard code the part parsing. What's HC? You mean classic mode? Oh, hardcore. You got to 60 on hardcore classic? That's crazy. Well, from what I've heard, the average is like level 12, where that's how high people are getting before they get killed. Yeah. If you got to level 60, then you somehow you're in the tail end of the distribution where you didn't get killed when you were level 12, where most other characters are getting killed, right? So you made it through. So congratulations. It's your first, you did it on your first try? Well, that's another congratulations. I hope you're not one of those level 60s that goes and ganks all the level 12s. Pass along the restraint and the generosity that others paid to you. It's a rogue. Oh, I see. You just stealthed you were like at level 12 you were like stealth all the time, right? Through every zone. Yeah, now that he's level 60, of course he's got that's like a job requirement of being a rogue in World of Warcraft, is especially a PvP, right? Is that you're gonna gank everyone else. So I guess you have to do it. I'm sorry. Sorry to say you shouldn't. It's like your job description. What chair do I have? Just a cheap office chair. It's got a nice headrest. It squeaks though. But it's nothing special. just like I just picked a random office chair on Amazon. Okay, what to work on next? Let me make sure the test is correct. I need to get reoriented. I think these tests are good. If anything, I might just give this a better name. Okay, so what to do next would be we need to do the UI built-in. We actually have to have bitstream remember its position in the stream, or the expression evaluator up here. See, the expression evaluator is hard because right now we're cheating with doing first. What we need to do is like starting with a position, which would default, I guess, to the composite itself. We would walk this chain. So this is a reference. This is a chain of reference parts. Getting like a spam call around the same time every day now. So we get a chain of reference parts. So that would be like A.B.C is the chain, right? And then every reference part could have indices. So you might have a 5 there. So that's a reference. So each reference has a name we have to look up somewhere. So if we start with the component in the composite, and then the name has to be one of its keyed children, then once we find that child, then that becomes the new, like, place we search for the next level, right? Yeah, I remember writing this in C and it was a pain in the ass. So maybe I'm going to punt on this for now. Okay, just making sure that it's not a critical message from work. Okay, so we're punting on this, and it's kind of obvious because I have like not just one, but I have 3 unwraps that I'm doing. So if we're just always going to the first child of, I should say, if we're always looking up the first name in the reference as the key child of the composite, that'll work for us for a while. So I'll punt on that. So instead, I guess we're doing this part because the return is done, right? Except for errors. So yeah, this would be next. Okay. So we know we're making a part. In the end, we know we're going to put it into the keyed children if it has a name. We have evaluate expressions, so we could turn the arguments into values. Maybe that's the first thing we do. Let args equal args dot iter dot map arg to, what did I call it down there? Context evaluate expression, okay. That's an expression. Dot collect into a vector. Although I wonder if we could just iterate through them. Instead of collecting, we would iterate through them along with the formal arguments of the format, and do the assignment into the part directly. That would probably be a better idea. Let me make a to-do there. To-do. Other than collecting, we could walk through the iteration along with the formal arguments of the format, assigning them as keyed children of the part. So right now we're just going to consume them and not use them, because I want to do something with them. And built-ins are different. So built-ins will just use the arguments as is, right? Because they have no formal names. So I guess that's the next part, is we need to see if it's a built-in. So we're going to construct at new time like a dictionary of built-ins. So let's declare that. Actually, I guess I could use a lazy for this. Oh, I don't want to use a mutex though. It's not too expensive to have ingestion have just a bunch of formats like built-ins. I think I call them elementals. That's a hash map from string. Actually, we can hard code that to a function that takes some arguments. So that would be so right now it would be vector, but we could turn it into that iterator later, right? Of data values. And it's going to yield, actually it's going to take data values in a part and right now not yield anything. No, it needs the context too. So mutable reference to a context and take some data values. And it needs the component it's working on, data. So mutable data component. I feel like I should make that a type first. Type elemental. What's wrong with my type? Oh yeah, that needs to be boxed, right? Actually, why would that need to be boxed? Because that's a trait. So yeah, that's a good reason. Okay, did I not have context? Oh, context has a certain lifetime. So that means that elemental also has that, has to have that same thing. Which makes sense, I guess. Bitstream. Why did I abbreviate that? Is that only because that's already a trait name? I should probably fix that and not use B. Oh, that means that this is also generic over some kind of bitstream. Well, no, that can be elided away, right? Hold on, let me think about that. Can I elide that away? Because it's just... Well, let's see if I can do it here. Is this the right type? No, I don't think it is because it's ingest that has that. I think that what I should do is end up boxing the bitstream object as a trait object, or box the reference, I guess. Can you box a reference? I don't know, but let's say that it is, so that we don't need. So hopefully we don't need these. I don't want to make it generic over some lifetime. I think I need to because the context is generic. Shoot. I could box the context. I could, right? I could box the context. That makes it a lot simpler. So boxed dyn. Well, can I just do this? Oh, that's not a trait, though. That is a generic structure. Oh, that makes things really complicated. Oh, ooh, ooh. So that has to be generic, that type there. And then that means the ingestion will end up will have to be also over some generic bit stream. But if these are functions, I don't need this here, do I? That's not a property of the type. Yeah, that doesn't need to be here. It's not generic. Hold on, let me think about this. A dynamic function of some borrow. Well, that's going to be a shorter borrow anyway. But I guess we have to say it. Oh, this is complicated. Yeah, I'm going down the path of painful Rust lifetime issues. Box everything. Following a Rust telemetry workshop, and you're learning a lot. That's great. Trying to get this type right. So what I want to have is a bunch of built-in functions called elementals, and the functions take a context, a data component, and a vector of data values, and it just basically parses bits out of the bit stream and assigns the value to that data component, and it might use these arguments. I think these can be unnamed because they'll just get names generated for them, right? Except for that might conflict with, it might tell me that this needs to live longer than that. So maybe I do a context there. I forget, can I do a where clause here? Maybe I can't do I have to actually declare it up here though. I can't do a where clause in a type. Where clauses are not allowed after the type for type aliases. Oh well. Should we leave that? I guess that becomes a problem of the ingestion, right? But those, see, those are all temporary. They're not actually stored. This is a function that takes those arguments, not a function that is generic over that lifetime. So maybe I don't even need to worry about that right here. Do I just like do this maybe? No, you can't do that. And I can't do that because it's not defined. And I probably can't do this either, right? Because it's going to say that it's missing some lifetimes. But see, those lifetimes are only used in the trait type. I'm thinking maybe really what I really need is a trait alias. Which so you can't have that yet. We don't have those yet, right? It's gonna say it's experimental. So there's a workaround for that, right? Which was to make a trait be derived from another trait, right? So trait. I forget how to do this. But anyway, I'm gonna. Yeah. I'll have to split this into two things. One thing that boxes it, and the other thing that kind of hides the gross details about the trait in it. I don't know how to specify this. Without doing what Pata said, everything boxed, everything being trait objects. Or expose all of the types all the way up through ingestion. You know, I guess that makes sense. We're already, if I just take this and pull it all the way up to the top. One's got away with having a hash map with the key with the use size and a phantom data and the value being the closure to call. Yeah, that's what I'm trying to do. I'm trying to make a map from names to closures. Well, or just functions, right? It could be a closure, it could be a function. I guess in my case, it's going to be a generic function because it has to be generic over the kind of bitstream that it is. Because that's definitely a trait. And doesn't really care about the borrow. Actually, maybe that's one of these I can remove. Can I just remove the context lifetime and maybe let it figure it out? This is wrong anyway. This is what I was trying to do. It's just that the problem is I have to specify bitstream lifetime and bitstream type here, which I didn't think I needed to, which I didn't want to have to do. But I guess it makes sense because if we're making elementals for a certain kind of bitstream, we have to know it at new time. So this has to be pulled up then, right? Yeah, okay, we'll pull it up. So that gets pulled up to ingestion. So then I can say, can I just get away with elide the lifetime and just do B? No, it wants a lifetime there. So I guess there's another lifetime bit stream. Then it's okay with it until we get down to here because I haven't filled all the stuff in. So do I have to actually say that here again? Guess I do. Here's where we would actually specialize the elementals. Like so far so good actually. We're not too bad. Okay, well let's see if I can pull this off then. So let's define some elementals. UI. Let's call it elemental UI. So it has to have the same argument list here. So of course we have to have the same generic stuff on it. And we have to give these names. So this is context. And this is data. And this is value. Okay, and then I should be able to do like, can I do the macro here? I think so, right? Not there. Here. UI elemental UI. So that needs the maplet. Use map lit hash map. Okay, we have a mismatch type. Oh, we have to box it. Expect to destruct hash map from string to boxed function. The full type is written to there found a hash map. Boxed function. Oh, the function is not a dynamic capital FN. I mean, it was close. Argument has type that, which causes map to have a type of 4A. Oh, is that how I'm supposed to declare it? 4A bitstream B. For all lifetimes. Okay. I guess that's what we have to do, right? I've never done this before. That that higher ordered lifetime trait stuff. So it would be like a 4. Wow, this is quite complicated. Is that how you do it? I guess not. It didn't like that syntax. Okay. So maybe not. Hold on. Let's paste that. Oh, no. Try again. Comment it out. Put this back to the way it was, like so. Actually, I guess I could leave that in, just remove the 4. There's no comma there. Is that the problem all along with that? Let's see. No, it just doesn't like that syntax for whatever reason. Three lifetimes. Well, yes. So if we want to be explicit, we have all these lifetimes. We're getting there. We have to fill all the damn lifetimes in here? Ah. This, I was hoping I could elide some of these things. Can I just elide like these and not name them because I don't use them? Okay, and then still have a problem constructing this though. It's this 4 thing that has to be in there, and I tried to do that and it didn't like it. Is it because it's because it has to be a lowercase fn, not a uppercase fn? No, it's close. We're getting close to that. Is your day job a male model? No. Box-Dine trait is the same as Box-Dine trait plus static. Maybe you want box plus some static. It doesn't seem to be complaining about the lifetime though of the box. It's complaining, I think the only difference here is this, I forgot what it's called, but that part's what's different, right? I need to try to add that somehow. So it's context, bitstream, and then data. Those are the only things that are different there. Oh wait, no, it's not comparing what it should be. It's that is that. The map has a type of that. I don't think I need to worry about that. The problem's something else, right? Mismatch types. Expected. I think it's because it's a dine fn and a lowercase fn doesn't fit that. I thought you could though make it fit. It's interesting that they actually wrote the type name out to it. Wow. Okay. I saw the word static in there though. Okay. Collections hash maps boxed dine standard ops fn. Put it here. That's a mouthful. You think it needs a nudge? I'm worried about this being way more complicated than it needs to be. I can just maybe not have a hash map at all. And just do a sequence of, I could just do a match. Instead of a hash map, I could just do a match and then call the elemental functions directly. That might be better. And actually that might the compile time, it might do a better job than hash map at runtime. Yeah, what if we just don't do any of this junk? So get rid of this. Yeah, this is just way too complicated. Well, we won't box it. But I do need to, well, no, I don't need to do any of this stuff. I already have it up here. Let's delete this stuff. The only thing I really needed was formats, right? Didn't need bitstream context or data. We have no elementals anymore. We don't have a bitstream or any of that junk. We don't have elementals. We don't have that. Or that. Or that. Okay, and then I had to put the bitstream down. Ingest is generic over some kind of bitstream. Am I getting to where I need to stop and go to work? I think so. Yeah, I need to stop soon. I'll stop after I get this this working. So right here, right? Where we're going to look it up, it would be match format, right? And if format matches UI, then we're going to do elemental UI. It wants to borrow the context mutably. It wants to borrow the data mutably, so that's part. And what's value again? Oh, that's the part. No, wait. Value. I don't need a value, actually. That is unnecessary because that is inside the data component. So there's no value. Okay, and I should, can I do that? How about as string? Yeah, it's not exhaustive. I'd rather match the format because this should say like format goes to do the rest of this. We'll do some basically non-elementals. Problem is that that needs to be a string to be a match, right? Can I like do as string and then actually use the format in here? So can I like say let b equal as a vector just to see if I can move it, right? Can I do this? Vex. Vec format. Will it let me do that? Format is a string? Oh, it is. How about if I do underscore? It's a reference to a string. Oh, it is. Okay, can I put the reference to the original string in there? I can, okay. I guess that's because this doesn't actually, as string doesn't consume the string, it takes a reference to the string. So we can still take another reference to the string. I can't move it because it's in the AST, which we borrowed. Okay, that's good. So we'll put format there. Or I guess we don't have to put an underscore because we have a to do, right? Oh no, we still get a warning. Okay. So this is where I intend to do the sub formats, like custom formats. And then we have all the elementals here, and it just works because it figures out the types. Because this is generic. This is telling me I don't even need that. It could be elided. Okay. We'll do that. So I don't need that. I can just elide this one, right? Nice. Okay, cool. That's even better. So then elemental UI, that's where we want to finally put the why is that open? Oh, right. I was playing around with that. Delete, close that. Um, I put that elsewhere in this file, right? Where we parse the bits out. Not there. Right here. So this part actually moves into UI now. Into here. This is data.value equals data value as an integer bits. And then I want to use the data.bound. Oh, wait. We have to actually pass that separately. No, is it context? No, it's separately, right? Yeah, this bound has to be passed into here. I don't know. Context part bound, I guess. And that is a option of an expression. We'll let it do the auto deref for me. Actually, I guess I'd have to do a as ref or something, right? There we go. So yeah, this the number of bits is bound on wrap because we need to turn that into an error later, and then we actually have to evaluate the expression, right? Let's do that as a separate line. So like let bound equal this thing, right? Evaluate expression. So it's context dot evaluate expression bound dot unwrap, and then I can just put bound in here. Oh, more than this, right? That returns me a result of a data value. So I would do dot OK dot. Now the type is option data value. So unwrap that. A lot of OKs and unwraps I'm doing. So now that it's a data value, it has to be if it's an integer. So if let data value integer bound equal. There's a lot of unwraps I'm doing. Else to do. Okay, now I'm getting more pings from work, so I should probably look and see what's going on. I need to end the stream anyway. Okay, bound should be an it's an I64. We need to turn it into a U size, right? Another conversion that we had that might be problematic. Irrefutable let pattern. It's useless. Replacing it with a let. Oh, right. It's like, can I like do it automatically? Yes. No, it wants it to be a match? What? With a let. It's like let else, right? Oh, right. It's like you put the else up here or something, right? And you remove this brace. And then you do that, and then you outdent this part. Yeah. And then it's, what is it saying? It's irrefutable. Else is useless. Remove the else. Okay, but what happened? Oh, I see what it's saying. This unwrap makes it irrefutable, right? I think. Okay, I'm really getting pinged now. This should work now again. Nope. Panicked and not yet implemented here. Oh, that's easy. Yeah, we do need to implement that. If the literal integer is I, then we evaluate this to be a data value integer I. And that's sum, or okay, right? It's always okay. Oh, and that, the type doesn't match. Shoot. Why did I use a I64? Because I wanted it to be signed, but if it starts out unsigned as a data value, all right, this type is wrong then. No, that's the I64. No, they're both compatible. Oh, I just need to dereference it to copy it. There we go, I did it. Actually, I think I am going to have a problem though, because I want my data values. Oh, they already are signed. Okay, never mind. No problem. No problem. Hey, look, we passed it. I think I gotta go though. So yeah, tomorrow we'll continue working on this. So I got a lot of to-dos to fill in. Got some to-dos here to work with the arguments. Yeah, there's just a lot of things to do, but I'm trying to make these tests down here force me to fill the things in that are marked to do. And it's just going to be an iterative process until we get the whole ingestion thing done. Yeah, goodbye hash map, exactly. So thank you for watching. Sorry if that was it was a little bit scuffed and rough today, but you know, that's how it goes. Someday good days sometimes, other times bad days, right? Hey, if you want to see more Rust, I have the perfect stream we're gonna raid. It's more chill. There's just background music and he doesn't talk, but you can chat with him in his chat. And he doesn't accept incoming raids. Okay, well, then we can't raid him. Wonder why he doesn't accept a raid. Okay, I will shout him out. If you want to see more Rust, I recommend going to Muse and stream. I can't raid him though. He won't let me. I'm not going to be able to do a raid then. There's no one else streaming that I know. So I'm just going to say, click on Newson's name if you want to go watch his stream. I'm not allowed to raid him. So that's it. See you later. Bye.